Students, welcome to our video lecture. In the last lecture, students, we have completed exercise 3.1, question number 3. Today, students, we are going to complete the exercise and start the basic concepts of exercise 3.3. Now, let us revise this formula. The angle subtended at the center of a circle by an arc of length L units, where the radius of circle is R units, is theta radian is equal to L by R, or arc length L is equal to R into theta radian. Students, theta must be always, in radian. Now, our sum is question number 4, exercise 3.1. I am starting with 3.1, answer number 4. In a circle of radius 100 centimeter, find the angle theta in degree subtended by an arc of length 22 centimeter. Arc length is how much, students? 22 centimeter. So we write angle theta radian is equal to L by R. So 22 by 100. So 11 by 50. This measure is, students, in radian. Now, all of you know the formula of degree measure. Degree measure is equal to 180 by R into radian measure. So this is 180 into 7 by 22 into 11 by 50. This many degree. 11 ones are 11 twos are. Then you can say this is 180 into 7 divided by 100. So 0 and 0 gets cancelled. So this is 9 and 5. 9 sevens are 63 by 5. Now execute formal division. So 5 divides 63. 5 ones are 5. 30. 5 twos are 10. So remainder is 3. Write in the form QR by D. This is R, this is Q, and this is D. So QR by D form gives us 12 integer 3 by 5. In the last lecture, students, I have taught you separate out the integer part and fractional part. So 12 degree plus 3 by 5 into 60 minutes. 5 ones are 5 12s are, so this is 12 degree, 36 minutes, 0 seconds. This is our answer, students. So this question, where arc length is involved, always remember, students, theta is in what? Radian. The question where arc length is involved, theta radian is L by R. So L is equal to R into theta radian. Converting radian measure into degree measure, we have the formula. Degree measure is equal to 180 by pi into radian measure. That formula, students, I have used. Okay, let us do sum number 5 of exercise 3.1. Now, the sum is, in a circle of diameter 40 cm, the length of the chord is 20 cm. Find the length of minor arc of the circle. Okay, students, I am drawing a rough figure. Say this is a circle. Say this is any chord AB. This is center C. Radius will be 20 centimeter as diameter is 40 centimeter. So radius R will be 40 by 2 and that is 20 centimeter. Length of the chord is also 20. We have to find length of this minor arc AB. Say which is a centimeter. Now students, this triangle is an equilateral triangle. So this theta will be 60 degree, and 60 degree is pi by 3 radian. All of you can understand. 180 degree is pi radian. So 60 degree is how much? So the answer is pi by 3 radian. Because as per the formula students, theta must be always in what? Radian. And that is why students I have converted this into radian. Now, length of minor arc AB, length of minor arc AB is L is equal to R into theta radian. R is 20, theta is pi by 3. So this length is written as students how much? Then students the answer is 20 into 22 by 7 into 3. So if I divide, it is 440 by 21 centimeter. 21 square is 441. So the answer is very near to 21, which is approximately 20.95 centimeter. 21 square is 441, so little less than you can say 21. Thus, students, the answer. Very important question. Now, sixth question. In two circles, arc of same length, subtends angles 60 degree and 75 degree at the center. Find the ratio of radii of this circle. A very important question for JEE means. Say students, there are two circles. So one circle is like this. And say the arc center C1, arc is AB, and radius is R1, and this is theta 1. Length of the arc is arc AB is having length L centimeter. Now what they have given, that this angle subtended at the center theta 1 is 60 degree. Okay. And other is a smaller circle. Say like this. Arc length is same. So let us suppose that this arc is CD, center is CD, radius is R, and angle subtended is theta, which is 75 degree. Arc length L is same, L centimeter. Or L units, or I can say L units. Now, what is our question? That in two circles, arc of same length, subtends angle 60 degree and 75 degree at the center, students, find the ratio of their radii. It means I need to find out the ratio R1 is to R. Now arc length L is equal to R1 theta 1 radian. Now I need to convert this theta into degree measure, radian measure. So radian measure is equal to pi by 180 into degree measure. 61s and 63s are just now. So this is pi by 3 radian, which is theta 1. Now here I am operating L1 is equal to L is equal to R2 theta 2 radian, because R length is same. So again the radian measure of the angle will be pi by 180 into 75. 15. I can say 15 5s and 15 12s. So this is 5 by 12 radian. Now arc length is same. So So L is equal to R1 theta 1 radian is equal to R2 theta 2 radian. So R1 upon R2 is theta 2 upon theta 1 radian. So 5 pi by 12 upon pi by 3. So this is written as 5 pi by 12 into 3 by pi. Pi cancels 3 ones are 3 fours are. So the ratio of radian is nothing but students 5:4. Why students I need to convert theta from degree into radian? Because this formula is only valid when theta is in radian. If theta is not in radian, we cannot use this formula. Okay students, 7th question. Find the angle in radian through which a pendulum swings if its length is 75 cm and the tip describes an arc of length. Okay students. Now I am erasing this formula also. I hope that all of you have clearly understood all the basics. Now students, we are going for the last question. Find the angle in radian through which a pendulum swings. Say suppose this is the base of the pendulum and you can say like this. It swings and subtends an arc. Length of the pendulum is radius, which is 75 centimeter. Isn't it? And tip describes an arc of length 10 centimeter. Okay. First arc length is L1 is equal to 10. This theta we have to find in radian. So as per our formula students, first part of the answer, theta radian is equal to L by R. So this will be 10 by 75. So this is 5 2s are and 5 15s are. I think students, our answer is to be found out in radian only. So this much is the answer. Second time, the length of the arc is 15 centimeter. Okay, this was L. Now L2 is equal to 15 centimeter. And let us take this as theta 1. Now theta will be L2 upon R 15 upon 75. And that is nothing but 1 by 5 radian. And third, L is 21 centimeter. Okay, so L3 is 21 centimeter. So correspondingly theta 3 will be L3 upon R and 21 upon 75. So students, we can cancel this by 3. So 3 7s are and 3 25s are. So the answer is 7 by 25. Yes. This is to be kept in radian only students. So no need to simplify further. No need to write answer in decimal. This is our final answer. Clear students? So this completes our exercise 3.1. We are done with students exercise 3.1. Now, before starting students exercise 3.3, I want to teach you certain formulas based on unit circle. I think Praveen sir would have explained this, but once again students, I am explaining based on unit circle. Say suppose this is x-axis and say this is y-axis. Let us say this is a unit circle. X-axis, y-axis. Understand this is circle. This is origin first quadrant, second quadrant, third quadrant, fourth quadrant. Here the angle starts with 0. At B it is pi by 2 radian, 90 degree. At A dash it is pi radian. At B dash it is 3 pi by 2. Then at A we have all even pi's, 0, 2 pi, 4 pi, 6 pi and onwards. At A dash we have all odd pi's, 3 pi, 5 pi, 7 pi, 9 pi and onwards. Here at a gap of 4, 4. So again this will be 5 pi by 2, 9 pi by 2, 13 pi by 2 and onwards. Here 7 pi by 2 plus 4, so 11 pi by 2 plus 4, so 15 pi by 2 and onwards. All as we see, all of it in first quadrant, all positive, it's all t functions. Here sine and cosec, here tan and cot, here you can say cos and sec. So I think sir has taught you this much, and all of you are aware of this much. Now students, based on this, today I am going to teach you how to find some values, how to find some application of this. Say suppose you want to know what is the value of sine 2 pi plus x, where x is acute. Students, all of you pay attention. Now 2 pi is up to a, one complete rotation, plus x, where I am telling you x is active. So this will lie in which quadrant? First one. 0 less than x less than pi by 2. Pi by 2 is 90. So I am considering generally x as active. So what I am trying to explain, whenever it is a multiple of pi, function remains same. So the answer of this is sin x only. Function will remain same and x will come in the answer. Now 2 pi plus x will fall in first quadrant. I told you up to 2 pi it is a plus x, where x is active. So in first quadrant all functions are positive. So the answer is sin x with a positive sign. So one more. Suppose I am writing cos 2 pi minus x. Whenever it is a multiple of pi, answer will be same function with this acute angle x. So the answer is cos x. Now students, 2 pi again lies at a. Minus acute angle x will fall in fourth quadrant. Sorry. And in fourth quadrant, cos is positive. So this answer will get a positive sign. Suppose I write sine of 2 pi minus x, multiple of pi, function doesn't change, answer is sin x. Now 2 pi minus x once again falls in fourth quadrant. In fourth quadrant, cos and sec are positive, sin is negative, so this will bear a negative sign. So the answer is minus sin x. So all functions with a multiple of pi, the answer will be the same function with that acute angle x. Depending upon the quadrant and all STC rule, we have to decide the sign. Okay, few more sums. Suppose I am writing sec pi by 2 plus x. Now remember, whenever it is a multiple of odd multiple of pi by 2, odd multiple of pi by 2, sec will change to cosec and cosec will change to sec. Sin will change to cos, cos will change to sin. Tan will change to cot and cot will change to tan. This students, we have to very carefully understand. So sec will change to cosec. Function changes. Now pi by 2 is at b plus x will lie in second quadrant. In second quadrant, sin and cosec are positive, but we have to determine or check the sign of function on the left, not the function function on the right. Sec in second quadrant will be negative because cos is negative. So this answer will be a negative sign. Sign of the left hand side is to be imposed, not of the function on the right hand side. Say one more. Tan of 3 pi by 2 minus x. Multiple, odd multiple of pi by 2. So tan will change to cot. So the answer is cot x. Now 3 pi by 2 is at b dash. Minus x will fall in third quadrant. In third quadrant, tan is positive. So this will bear a positive sign. Say one more. Cos of 7 pi by 2 minus x. Now again 7 pi by 2 falls at b dash. Minus x third quadrant. Third quadrant tan and cot are positive. Cos is negative. Multiple of pi by 2, so cos will change to sine. Negative sign is because in the third quadrant cos is negative. So you can do n number of sums of this formula. The basic instruction is to understand two rules. Multiple of pi, function doesn't change. Multiple or multiple of pi by 2, function changes. What are the changes? Sine to cos, cos to sine, sec to cosec, cosec to sec, tan to cot, and cot to tan. Now today I am going to do simple sums based on this formulas. Students, exercise 3.3, I am going to do questions 1 and 2. Only two sums. Exercise 3.3, sorry. Question 1. Find the value, prove that sorry. So LHS is sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4. Now students, this table of values we have already studied in your 10th standard. Yes or no? This table of values which I am showing here, t function 0 degree, 30 degree is pi by 6 radian, 45 degree is pi by 4 radian, 60 degree is pi by 3 radian, and 90 degree is pi by 2 radian. This all you know. We have to remember three values: sine, cos, and tan. Remaining we can easily derive. Sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2. This is root 3 by 2 and 1. Write in reverse order. 1 root 3 by 2, 1 by root 2, 1 by 2, 0. Tan is sine from cos, 0. Here 1 by root 3, here 1, here root 3, and here undefined. Cosec will be reciprocal of sine. Sec will be reciprocal of cos, and cot will be reciprocal of tan. No need to mug up. Now, if I want to find this value, students, if I want to find this value, how to do? Now, you know pi by 6 radian is 30 degree. So, sine pi by 6 is 1 by 2 and its square. Cos pi by 3 is half and its square. Tan 45 is 1 and its square. So, this is 1 by 4 plus 1 by 4 minus 1. So, this is half minus 1 and that is minus half. And this is your RHS. We have to do this only. So, this you know, but in your 10th standard, angles were written in degree. Now, students, this angles are written in radian. That is the only change. Okay, second question. And erasing this. Prove that twice sine square pi by 6 LHS twice sine square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3. This we have to prove as 3 by 2. Okay, now students, the main thing is to find the value of cosec square 7 pi by 6. Here I write cosec 7 pi by 6. Always try to express your numerator as a number given in the denominator. What is the technique? Always try to express your numerator as a number given in the denominator. So 7 pi can be written as 6 pi plus pi by 6. The number given in the denominator is 6. So I need 6 in the numerator. Split 7 in terms of 1 divided by 6, so that will be 1. Now execute individual division, 6 pi by 6. So this becomes pi plus pi by 6. Now visualize this as x. Just now we did cosec pi plus x. This is active angle, so the answer is cosec x because it is multiple of pi. Now pi plus pi by 6 will fall in third quadrant. In third quadrant, cosec is negative, so this will be a negative sign. Now sin pi by 6 is 1 by 2, so cosec pi by 6 will be 2, and negative sign is already there. So when I substitute the values, our LHS is continuing. This is 2 sin pi by 6 is 1 by 2 square, cosec pi by 6 is minus 2 square, and cos pi by 3 is 1 by 2 square. So this will be 2 by 4 plus 4 into 1 by 4. So this is half plus 1, which is 3 by 2, and that is your RHS. So the formulas which I told you, multiple of pi function doesn't change, multiple of pi by 2 always function changes. Check the angle, accordingly give the numerical sign by LSTC rule. That's all. Once again, students will revise this in the next lecture. Try to do this very, very perfectly. Thank you, students.